Hello friends. So, welcome to lecture series on multivariable calculus. So, we were dealing with maxima minima of two or more than two variable functions. Now, we will deal with Lagrange multipliers. So, what Lagrange multiplier method is, let us see. In many practical problems, we need to find the maximum or minimum value of a function f x1 x2 up to xn when the variables are not independent, but they are connected by one or more constraints of the form gi x1 x2 up to xn equal to 0 for I from 1 to k, and generally n is greater than k. Now, suppose you have a constraint optimization problem. We call such problems as constraint optimization problem, that is, you have to find out maximum and minimum value of some function f subject to some conditions. Some conditions are given to you. Conditions are gi of x1 x2 up to xn equal to 0. Okay. So, hence these variables x1 x2 up to xn are not independent, they are connected by some relations. So, if they are connected by some relations, so how can you find out maximum or minimum value of function subject to those conditions? Okay. How can we solve those problems? Suppose you have to find a point P x y z on the plane x plus 2y minus 3z equal to 5, that is closest to the origin. So, what is the plane? Plane is x plus 2y minus 3z equals to 5. Now, in this plane there are so many points. Okay. You see this plane, this is the equation of plane. Plane is x plus 2y minus 3z equals to 5. From all those points, we have to find out that point which is closest or nearest from the origin. Okay. So, this is some origin. Okay. So, let us suppose that point is x y z. So, distance from the origin will be under root x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. So, you have to find out the minimum value of this d subject to this condition. Okay. So, what is our problem? Problem is minimizing this objective under root x square plus y square plus z square subject to x plus 2y minus 3z equals to 5, or this problem can be rewritten as minimum of, now finding minimum of under root or finding minimum of the inside expression are one and the same thing, the problems are equivalent. So, we can say that finding minimum of x square plus y square plus z square subject to x plus 2y minus 3z is equals to 5. Okay. Now, the first way out is the method of substitution. So, what is the method of substitution? Now, this is an equation having three unknowns. You simply eliminate one of the variable in this expression with the help of this expression. Okay. So, let us compute say x. So, what will be x? It is 5 minus 2y plus 3z. So, what will be f? F will be 5 minus 2y plus 3z whole square plus y square plus z square. So, now it is something like unconstrained problem. I mean, now it is a two variable problem without any condition, and you have to simply find the minimum value of this. So, our old technique will work out, that is, you find out the critical point of this function. Okay. And using the second order partial derivative test, you can check where that point is the point of local minima or local maxima. So, that will give the minimum value of this function. So, what is fy and fz? Put it equal to 0. So, this implies it is simply 2 times 5 minus 2y plus 3z into minus 2 plus 2y is equals to 0, and the second equation is 2 times 5 minus 2y plus 3z into 3 plus 2z equal to 0. So, the equations are simply So, equations are, it is you can easily find out the two equations, one equation is this, second equation is this, and when you solve these two equations, so you can find out the values of y and z. Okay. Of course, the second order derivative test will give the minimum value, I mean point as local minima. Okay. Substituting those y and z over here, you can simply find out x. So, that x y z will be a point which is closest from the origin, lying on the plane. Okay. So, what is that point? That point is simply 5 by 14, 5 by 7 minus 15 by 14, that you can easily find out solving these two equations simultaneously. Okay. And then finding the values of y and z, you simply substitute it over here, find the value of x. Okay. Now, to solve a constraint maximum or minimum problem by substitution do not always work smoothly. You see, here we have a linear equation. So, we have easily substituted, we have easily find out one variable with respect to other two and simply substituted over here, but this may not always work. We have some non-linear terms also which is difficult to remove from this expression. In this expression, use this relation. Okay. So, we have some method to solve all those cases. So, that method is Lagrange multiplier method. Now, what is that method? Now, suppose we want to maximize or minimize a function f x y, we are considering here two variable function, the same process will go for 3 or more variable functions also, subject to g x equal to 0, g x y equal to 0. Now, let the extreme point of f x y subject to the constraint g x y equal to 0 is k, okay, and is attained at x naught y naught. By examining the contours of f, we can see that at the extreme point the curve g x y equal to 0 must touch the level curve f x y equal to k, because if the curve g x y equal to 0 cut cross the level curve, then one can still move the point along g x y equal to 0 so as to increase or decrease the value of f. So, what does it mean? Let us see from the graph. You see, say this is the equation of g x y equal to 0. This graph which is given here in the bold line, say this graph is a graph of g x y equal to 0. Okay. Now, you plot different contours of f, say f x y equals to m1, f x y equals to m2, f x y equal to m3 and so on. Okay. We can simply observe that at the point x naught y naught, okay, if we draw a contour which touches at this point, will give the extreme values, because if we go inside the region where it cuts, where it intersects g x y equal to 0, then the value of the function may increase or decrease. I mean, if you move further, the value of the function may increase or decrease further. Suppose this is the point of local maxima where the function attained maximum value, then if you go in the region below the curve, then the value of the function will decrease and continuously decrease. Okay. So, this can be understood by following say the first example. Let us discuss this example. So, what I want to say basically, you see, in the first example we have to find out the maximum minimum value of the function and subject to condition is x square plus y square equal to 1. Okay. So, now this is our g. Okay. Now, let us draw different contours of f. So, if you have so this is a straight line basically. So, at here f equal to 3x plus 4y is 0, because it is passing through origin. Okay. Now, when it is 1, so suppose at this point it may be 12. Okay. When this is 4 and this is 3. Okay. at some point here it may be 11, at some point here when it touches the circle it may have some other value, say k. Now, when you come inside this circle at this point and at this point, the function have some value, function 3x plus 4y have some value, but as you move inside, the function, the value of the function decreases continuously and it is 0 here. So, function will attain, this function will attain maximum value when it touches this this circle over here. Okay. And again when you move inside this circle, this will give the minimum value over here when it touches the circle over at this point. Okay. Because further decrement in the value of the function subject to this condition is not possible, because if you take a function over here, we want all those points which lies on the circle subject to this condition. We are talking about maximum minimum of this f over this condition, I mean all those points lying on this circle. Okay. Now, if we are saying that this is not a point of maxima, this is the point of maxima. So, all those values when we move inside the region, the value of f decreases, here it is 0, and when we move away from this point, value of f increases. Okay. But we are interested to find out those values, those x and y which are on the circle x square plus y square equal to 1. Okay. So, now at this point, if you are talking about this point, at this point this will be simply gradient of f. Gradient of f is always normal to a surface, normal to a curve, and at this point this is also the gradient of g, the same direction will be the gradient of g here is x square plus y square minus 1 equal to 0. Now, at this point gradient of g and gradient of f are same, I mean direction are same, this means they are parallel, and parallel means gradient of f will be some lambda times gradient of g. Similarly, here gradient of f and gradient g are parallel. So, this means at the point of extrema, if we have to maximize or minimize a function subject to some condition g equal to 0, then at that point gradient of f is always equals to lambda times gradient of g, because gradient of f and gradient of g are parallel vectors. So, they are parallel, this means one vector can be written as lambda times other vector. Okay. So, this is the main concept of Lagrange multiplier method basically. Now, here what is gradient of f? It is 3 I cap plus 4 j cap. What is gradient of g? It is 2x I cap plus 2y j cap. Okay. Del g by del x I cap plus del g by del y k cap, and lambda is called Lagrange multiplier. This lambda is called Lagrange multiplier. So, what is gradient of f is equal to lambda times gradient of g. So, this implies 3 I cap plus 4 j cap will be equals to 2x I cap plus 2y j cap. This implies lambda times, this implies 2x lambda will be equals to 3 and 2y lambda will be equals to 4. So, here x will be equals to 3 upon 2 lambda, and here y will be equals to 2 upon lambda. Now, this point must be on circle also. So, this must satisfy x square plus y square equal to 1 also. So, when you take x square plus y square equal to 1, so this implies 9 by 4 lambda square plus 4 by lambda square will be equals to 1. This means 9 by 16, 9 plus 16 will be equals to 4 lambda square, and this implies lambda square equals to 25 by 4, implies lambda is equals to plus minus 5 by 2. Okay. Now, when lambda is 5 by 2, so we were solving this problem, that is maximizing and minimizing f x y equal to 3x plus 4y subject to x square plus y square equal to 1, and we have just obtained that x equals to 3 by 2 lambda and y equal to 2 by lambda, where lambda is plus minus 5 by 2. So, what will be the values of x and y? X will be, when you substitute, so for lambda equals to 5 by 2, x will be equals to it is 3 by 5 and y will be equal to 4 by 5, and for lambda equal to minus 5 by 2, x will be minus 3 by 5 and y will be minus 4 by 5. Okay. So, where these points are? These points are on the circle. This is a unit circle of center 0 0 radius 1. Okay. It is 1 comma 0, minus 1 comma 0, it is 0 comma 1 and 0 comma minus 1, and this point is somewhere here, which is 3 by 5 and 4 by 5, and this is a point where this function attains maximum value. What is that value? When you substitute x as 3 by 5 and y as 4 by 5, it will be nothing but 9 plus 16, 25 by 5, that is 5. So, that is the maximum value of f. And what is the minimum value of f? Minimum value is obtained at x equals to minus 3 by 5 and y equals to minus 4 by 5, and where this point is? This point is somewhat here, which is minus 3 by 5 and minus 4 by 5. So, this is the f, which is the minimum value of this function. So, the maximum value of function is 5, which is at this point, and the minimum value of function is minus 5, which is at this point. So, let us try to solve problem 2. The temperature at a point x y on a metal plate is given by T x y is equal to 4 x square minus 4 x y plus y square. An ant on the plate walks around a circle of radius 5 centered at the origin. So, we have to find the highest and the lowest temperatures encountered by the ant. So, you have a metallic plate, the temperature of the metallic plate is governed by that expression, and ant is moving on that plate following a circular path. Circular path is centered at origin and radius is 5. So, basically we have to find out the maximum and minimum value of T x y, which is given as 4 x square minus 4 x y plus y square subject to x square plus y square is equals to 25. Okay. Because ant is following this route, ant is following this circle, is moving on this circle, and when ant is feeling the maximum temperature and when it is feeling at the lowest temperature, the points that we have to find out. So, basically we have to maximize or minimize this function subject to this condition. So, how can we do that? We can take gradient of t is equal to lambda times gradient of g, where g is x square plus y square minus 25 is equal to 0. This is by Lagrange multiplier method. What is gradient of t? It is 8x minus 4y I cap plus minus 4x plus 2y j cap is equal to lambda times 2x I cap plus 2y j cap. So, this implies 8x minus 4y is equals to 2 lambda x and minus 4y plus 2y is equals to lambda into 2y. So, from these two equations this implies x lambda by 2 will be equals to 2x minus y from here, and from here it is minus 2x plus y, which is equals to lambda y. So, from these two equations what we have obtained? This implies x lambda by 2 is equals to minus y lambda, and this implies lambda times x plus 2y is equal to 0. So, now we have two possibilities, either lambda equal to 0 or x plus 2y equal to 0. So, first we will take lambda equal to 0. So, case 1 when lambda equal to 0. If lambda equal to 0, this means 2x minus y equal to 0, the same equation obtained from this expression. So, 2x minus y equal to 0, this implies, so y is equal to 2x. Now, this expression, this x and y must satisfy this equation also, because aunt is moving on the circle. So, you substitute y equal to 2x here. So, it will be x square plus 4x square is equal to 25. So, 5x square is equal to 25, and this implies x is equal to plus minus under root 5. So, what will be the point? Point will be when x is under root 5, y will be 2 under root 5, and when x is minus under root 5, y will be minus 2 under root 5. And what will be t at this point? T at this point will be when you substitute. So, what is t? T is basically, when you carefully see on t, it is 2x minus y whole square, and 2x minus y is 0. So, at both this point t will be 0. So, this means this point and this point gives the minimum value of the temperature, or temperature is lowest at these points. Okay. Now the case 2, when x plus 2y equal to 0. If x plus 2y equal to 0 means x is minus 2y. Now, when you substitute x equal to minus 2y here, it is 4y square plus y square equal to 25. So, this implies y is equal to plus minus under root 5. So, therefore, then the points will be when y is plus under root 5. So, x will be minus 2 under root 5, and when it is minus under root 5, then it is 2 under root 5. Okay. And values of t at this point will be when you substitute x as minus 2 under root 5 and y as under root 5. So, this value will be 2 into 2 4 under root 5 plus 5, that is 125, and here also it is 125. So, this is the point, these are the points where t is maximum. Okay. So, when aunt is moving on the circle, when the aunt comes at this point or this point, the temperature is minimum, that is T equal to 0, and when the aunt comes at this point or this point, then temperature is maximum, which is 125. Okay. So, that is how we can solve this problem. So, now the next problem, find the volume of the largest closed rectangular box in the first octant having 3 faces in the coordinate planes and the vertex on the plane this. Okay. So, you have to find out the volume of the largest rectangular box, okay, satisfy this condition. So, volume of a rectangular box will be given by x into y into z, okay, length into breadth into height, and a subject to what is the condition. So, this we have to maximize, yes. So, this we have to maximize, and the condition is basically x by 1 plus y by 2 plus z by 3 is equals to 1. Subject to this condition, we have to maximize this value. So, again we will take, so let us suppose this is g. So, gradient of v will be equal to lambda times gradient of g, and this implies yz I cap plus zx j cap plus xy k cap will be equal to I cap plus 1 by 2 j cap plus 1 by 3 k cap lambda times. So, yz equal to lambda, xz equals to lambda by 2, and xy is equals to lambda by 3. Now from here what we obtain? You multiply this by x, this by y, this by z. Okay. So what you will obtain? X y z will be equals to x lambda will be equals to y lambda by 2 will be equals to z lambda by 3. Now this point, this condition must satisfy this also. So what we are having from here? It is x by 1 plus y by 2 plus z by 3 is equals to 1. You multiply the entire expression by lambda. So it is x by lambda into 1 by 1, y lambda by 2 plus z lambda by 3 is equals to lambda. Okay. Say this is equals to k. Okay. So this is a k plus k is equals to lambda. So this implies lambda equals to 3k. Okay. So from here what we obtain? X lambda is equals to y lambda is by 2 is equals to z lambda by 3 will be equals to lambda by 3. Okay. Okay. So what will be x now? So x will be equals to 1 by 3, y will be equals to 2 by 3 and z will be equals to 1. Okay. So you can simply substitute, you can simply check here. So x 1 by 3 plus 1 by 3 plus 1 by 3 is 1, 1 minus 1 is 0. So we satisfy this equation also. Okay. So this is the point where it attains maximum value, and maximum value of v will be nothing but 1 by 3 into 2 by 3 into 1, that is 2 by 9. So that is how we can find out, we can solve this problem. Now suppose you have two constraints, you have to maximize maximum, or you have to find out the maximum minimum value of function f x y z subject to two conditions. So how can you find, how can we use Lagrange multiplier in this case? We can simply take here gradient of f as linear combinations of gradient of g1 plus gradient of g and gradient of g2, that is lambda times gradient g1 plus mu times gradient g2. So and this condition also must hold. Okay. That is, we take a gradient of f as a linear combination of gradient of the constraints, gradient of g1, gradient g2, gradient g3 and so on. Okay. Now let us solve the first problem in this case. So here we have to find out the minimum value of this function. Function is x square plus y square plus z square, and subject to conditions are x plus 2y plus 3z equals to 6, and second condition is x plus 3y plus 9z is equals to 9. So how can we solve this? So gradient of f we can take as lambda times gradient of g1 plus mu times gradient of g2. So what is g1 from here? G1 will be x plus 2y plus 3z minus 6 equal to 0, and g2 from here will be x plus 3y plus 9z minus 9 equal to 0. So that will be gradient of g will be 2x I cap plus 2y j cap plus 2z k cap is equals to lambda times I cap plus 2j cap plus 3k cap plus mu times I cap plus 3j cap plus 9k cap. So you form the equations from here. It is 2x equals to lambda plus mu, 2y is equals to lambda 2 lambda plus 3 mu, and 2z equal to 3 lambda plus 9 mu. Okay. And next is these two conditions also must hold. So you simply substitute x here, y here and z here. Again here also you simply substitute the values of x, y and z. So, you will get back two equations in lambda and mu. You solve those two equations, find out the values of lambda and mu. When you get the values of lambda and mu, you simply substitute here, you find the values of x, y and z. That will give the point where this f attain the minimum value. So, this is how we can solve this type of problems. Similarly, we can solve the second problem also. So, thank you.